In 1945, at a site called Trinity, an event occurred, an event which changed the course of history and ended World War II. This would be the detonation of the first atomic weapon under the leadership of J. Robert Oppenheimer and General Leslie Groves. This was done at a site called Trinity in Los Alamos, New Mexico. 3 weeks later, the world was stunned by the atomic attacks on the cities of Hiroshima and Nagasaki, ending World War II. Since the splitting of the atom in 1932, it had taken this long for mankind to develop this type of energy. But is it possible that there was a naturally occurring nuclear reaction billions of years earlier? What follows is the story of the Oklo naturally occurring nuclear reaction in Gabon, Africa. I'm Andrew West. This is Up Close, and thank you for viewing.
What if the Earth is much, much older than we previously thought? So if we look around, there are clues to be found all around the world, from the Great Pyramids of Egypt to the Sacsayhuaman ruins in Peru, that point to the possibility that advanced prehistoric civilizations may have existed on this planet tens of thousands or even millions of years ago. And in this article, we'll talk about one of the intriguing finds.
So let me tell you about the Oklo effect. One of the results of working on the Atomic Energy Commission was that I became aware of some beautiful work that the French Atomic Energy Commission was doing. They were, of course, the French have a big nuclear generating power. Most of their electric power comes from nuclear energy. And they get the uranium for this from some mines in Gabon in West Africa.
In 1972, French scientists were testing some uranium taken from the Oklo mine in Gabon, Central Africa, when they noticed something odd. They had a lot less usable uranium than they thought they did. Enough uranium to make 6 nuclear bombs was just missing. Normally, the uranium found in ore comes in 3 different varieties, or isotopes, each with a different number of neutrons in its nuclei. Since their atomic makeups are slightly different, they all react in different ways.
When you think of nuclear reactors, you probably think of giant man-made energy plants, only made possible due to the amazing effort of human engineering.
That might not sound like a lot, but spread out over the giant mine at Oklo, it looked like 200 kilograms of uranium-235 had disappeared.
An ancient 2 billion year old nuclear reactor discovered in Africa. 2 billion years old.
But it turns out that humanity hadn't actually managed to do anything the Earth was not able to do naturally, and it had been doing so for as long as 2 billion years.
Now, in a natural, uncontrolled reaction, all of those neutrons being released would be moving way too fast to split an atom. Instead of hitting another atom, they'd mostly just rocket away without hitting anything, and the reaction would simply stop. But this didn't happen at Oklo, because the deposit also had the third major ingredient, a way to control the reaction. The Oklo deposit was full of water. Groundwater, to be precise, which continuously flowed into the site, slowing the neutrons down enough that they had time to hit other atoms of uranium-235 and keep the chain reaction going.
Another objection to the theory of a naturally formed nuclear reactor is because several researchers noted that there is no time in history at the site where the uranium ore would be rich enough in uranium-235 for a reaction to take place naturally.
In the past, the material that nuclear reactors need, uranium-235, was much more abundant on planet Earth. And through a cycle of chain reaction, cessation, cooling, and repetition, a nuclear reactor bursted into life for hundreds of thousands of years, before eventually exhausting its supply of fissionable material. One theory suggests that the uranium in question was covered with groundwater, which was able to moderate the neutrons that were involved in the reaction, much like water and cooling rods would do in a man-made nuclear reaction.
It happened in May of 1972. Workers were at the nuclear fuel processing plant in France. They found that ore, sourced from a mine in the Oklo deposit in Gabon in Africa, was formed over 2 billion years ago, had over 440 pounds of uranium-235 that appeared to be missing. This was scary because that much uranium could make at least 6 nuclear bombs. After scratching their heads for weeks, researchers at the French Atomic Energy Commission, the CEA, came to the conclusion that the missing uranium must have gone through a nuclear fission and split into other atoms, which was extremely unlikely, as this would require some very specific conditions.
Uranium ore should contain the same ratios of different isotopes no matter where it's found in the world. So the French scientists knew that in the ore they were studying, they were supposed to find a concentration of uranium-235 that was exactly 0.72%. But it turns out that they only had a concentration of 0.717%. That might not sound like a lot, but spread out over the giant mine at Oklo, it looked like 200 kilograms of uranium-235 had disappeared.
The results of the research were made public at a conference of the International Atomic Energy Agency, and although many labeled the finding wondrous but naturally occurring, others concluded that this setup could not have occurred naturally, and therefore this setup must have been man-made.
The Oklo reactors are located in the Oklo region of Gabon in West Africa. They aren't actually active anymore, and they haven't been for over 1.5 billion years. But it's pretty clear that something used to be going on. That something? For around 300,000 years, the Oklo reactors were home to a series of stable nuclear fission reactors.
So what if we consider for a minute that our dating technique is not foolproof? Maybe we did not find the oldest piece of the planet after all, or perhaps radiocarbon dating is not as reliable as we think it is, or we'd like it to be. And what if the Earth is much, much older than we previously thought?
After a few weeks of frantic investigation, the scientists realized that they were never going to find the missing uranium because it had been gone for 2 billion years. What they had discovered was the remains of an ancient natural nuclear reactor. Some physicists had theorized that certain kinds of nuclear reactors could exist naturally, but only under very specific conditions. And it turns out that the uranium deposits at the Oklo mine and the area around it fulfilled all of those conditions. Basically, a natural nuclear reactor needs the same ingredients that modern nuclear power plants do. You need an atom that you can split pretty quickly and easily, you need neutrons to do the splitting, and you need a way to control that reaction so once the atoms start breaking apart and releasing face-melting amounts of energy, you don't have a nuclear Armageddon on your hands.
The strangest thing about the Oklo reactor was its lack of toxic waste. Us humans store our nuclear waste in places like the Yucca Mountain, but somehow, nature had disposed of the waste safely. According to some researchers, the Oklo reactor trapped its toxic waste in a compound known as aluminophosphate and rendered it safe. But don't be too worried about being caught in the middle of a random natural nuclear reactor. As we stated near the beginning of this video, the only reason the Oklo reactor was ever able to gear up and start reacting was because of the extreme levels of uranium-235 that was around on planet Earth at the time. In our current era, there is nowhere near enough U-235 in the natural world to start a new natural nuclear reactor.
When the first ingredient, an atom of uranium-235, is struck by the second ingredient, a stray neutron, the atom becomes so unstable that it splits, releasing a ton of energy, plus a few more neutrons that fly off and split other uranium atoms, creating a chain reaction. And
one theory suggests that the uranium in question was covered with groundwater, which was able to moderate the neutrons that were involved in the reaction, much like water and cooling rods would do in a man-made nuclear reaction. When the groundwater had all boiled away, the reaction stopped, until the water seeped back into the cave and repeated, and, well, you get the general idea.
Now, we have recent evidence of ancient civilizations' nuclear wars. We have images of strange-looking bombs and cloud-like explosions from the Sumerian tablets and the Sumerian temples, which means that at that time they knew of this type of atomic power, and perhaps they were trying to record the fact that it was used. Now, were they referring to what happened in their area or their past, or were they referring to something that happened in Africa or in India?
Now, in a natural, uncontrolled reaction, all of those neutrons being released would be moving way too fast to split an atom. Instead of hitting another atom, they'd mostly just rocket away without hitting anything, and the reaction would simply stop. But this didn't happen at Oklo because the deposit also had the third major ingredient, a way to control the reaction. The Oklo deposit was full of water. Groundwater, to be precise, which continuously flowed into the site, slowing the neutrons down enough that they had time to hit other atoms of uranium-235 and keep the chain reaction going.
What's surprising is that for a massive nuclear reactor like this, the impact on the environment around it should have been devastation, but instead it was only limited to around 130 feet on all sides, and the nuclear waste was held in place because of the geological shape of the site, which again may have occurred naturally, but to many researchers this seems more like it was designed, man-made, that is. So was this ancient reactor just a natural marvel, as many publications claim, or could it have been constructed by a bygone civilization millions of years ago?